So hello everyone, good evening, good evening, good morning, or good afternoon. So kung what time man ninyo i-watch na video. So I decided na mag-record na lang og lecture, no? I-record na lang ning lecture since we don't have enough time to meet or to have a face-to-face class, no? Since tay exam na gyud and wala na tay time, no? So mag-record na lang ko for you to watch and makover na to ning topic. So, under this topic, no, lecture for point of 4, evaporation and evapotranspiration. So, under this kanang topic, we are going to, excuse me, to discuss the concept of evapotranspiration, explain the concept of evapotranspiration process, now, elaborate the factors affecting the evapotranspiration, discuss the techniques on determining evapotranspiration, and also, no, mag-solve tog problems related to evapotranspiration measurements. So I have a question here. What is the difference between evaporation and evapotranspiration? So this question is supposed to be, I will be asking you about your first perception. So what's the difference between evaporation and evapotranspiration? But since nag-record naman ko and kung makapanguto na sa inyo, so I will be introducing na lang the brief difference nila, and later on we will discuss no deeply. So evaporation or the transformation of liquid water to water vapor, no, and transpiration, no, these are the water vapor emission from plant surfaces, no, and the outflow process of water. So evapotranspiration is if you are going to combine the two process, no, of water surface evaporation, the soil moisture evaporation, and also the plant transpiration. So these are some of the facts, no, about evaporation and evapotranspiration. So first, two phases of the hydrologic cycle of a particular interest in agriculture are evaporation and transpiration. So about 3/4 of the total precipitation received on land areas of the world returns directly to the atmosphere by evaporation or transpiration. So most of the balance returns to the ocean as surface or subsurface flow. So another definition or facts about evaporation, it is the transfer of liquid surface water into vapor in the atmosphere. The water molecules, both in the air and in the water, are in rapid motion. So it occurs when the number of moving molecules that break from the water surface and escape into the air as vapor is larger than the number that re-enter the water surface from the air and become entrapped in the liquid. Evaporation, which may occur from water surface, wet leaf surfaces, or from water on soil particles, is important in water management and also in conservation. So another, wind increases the rate of evaporation, particularly as it disperses the vapor layer found directly over the evaporating water surface under stagnant condition. So, and the more wind, the more the evaporation will increase. Kumbaga, mas paspas ang evaporation if kanang paspas sad ang wind, no? Kusog sad ang wind. So, because of this mixing, the characteristic of the atmosphere above the surface are of interest, as might be expected from the decreased concentration of water molecules. Evaporation increases with decreased vapor pressure. So hence, the rate of evaporation decreases slightly with increases in the salt content of the water. So ang kanang salinity, no, reduces evaporation since ang dissolved salt ions, no, nagalower siya sa free energy sa mga water molecules, no. So example ana is kanang reduce the water activity and kanang reduce the saturation vapor pressure, no, above the saline water and a given water temperature. So let's move on sa transpiration. Transpiration, it is the process through which water vapor passes into the atmosphere through the tissues of living plants. The amount of water that passes through plants by the transpiration process is often a substantial portion of the total water available during the growing season, and besides energy availability, it is also governed by total leaf area and plant stomata control. So it can vary from near zero to as much as 2,000 mm per year, depending largely on the water available, type of plant, density of plant growth, amount of sunshine, climatic dryness, and soil fertility and structure. So less than 1% of the water uptake is retained by the plant. So the amount of water that passes through the plant is depende siya or mag-consider siya sa kaning water available during the growing season, and also maglaylay sad siyang ang energy availability niya depende sad sa kadako og kagamay sa leaf og ang iyahang stomata control, kasi we have different species or of kanang plants so has lahi-lahi sad og stomata control sab, which is lahi-lahi sad og kanang matranspire nga water lahi-lahi sad ang transpiration lang nga process. Evaporation plus transpiration. So the rate of evaporation or transpiration increases with a rise in temperature of the surface because saturation vapor pressure at the surface increases with increase in surface temperature. So the rate of evaporation increases as the temperature increases because so this makes sense because if higher ang temperature, more molecules daw ang nagamove, moving faster. Therefore, as the kanang temperature increases, the more evaporation daw. So in areas with growing plants, water passes into the atmosphere by evaporation from the soil surfaces and transpiration from the plants. And evaporation and transpiration are difficult to separate since magkuyog man gyud na sila duha. So if you have a plants here, naasad sila naasay soil which dito pod mag-evaporate pod ang water, and you have a plants through transpiration, and sa iyang environment sad na other na soil na body of water which is evaporation. So it is kanang difficult to separate and consider together as one and called evapotranspiration rather. Estimated evapotranspiration or ET is needed for determining irrigation requirements for crops as well as water storage in ponds and reservoir. So if we know the kanang evapotranspiration of a certain crops, makatabang siya sa agriculture and also sa kanang determining irrigation requirements. So for example, already the kanang evapotranspiration sa imong crops, so makabalo ka how much water you need to kanang irrigate for that certain crops. So high evapotranspiration from such crops as grass may be beneficial for the removal of soil water. So na mga crops or grass nga kusog sila mag-evaporate or mag-transpire og water, which is kana makatabang siya sa soil water removal water or removal of kanang water removal from the soil. So naatay figure diri, kaning figure is nagpakita ni siya unsa tong mga factors na maka-affect sa evaporation or transpiration or evapotranspiration sa isa ka crop or sa mga crops, different crops. So weather parameters, so of course mag-vary ang evaporation or transpiration sa current weather of that specific place. And also we know that different crop na sila lain-lain mga characteristics, which is ang transpiration maglahi-lahi sad. So management environmental factors if unsa siya pag-manage if ang place is very controlled, no. So if very controlled, it's either paspas ang pag-evaporate sa water vapor or pag-transpire sa water vapor, no, I mean nga na, or there's no management at all. So kana sila, no, ang mga factors nga na mag-vary ang evapotranspiration. So factors affecting the evaporation process, we have the radiation, second, temperature. So like I said earlier, the higher the temperature, the faster it evaporates. Wind speed, the more wind nga nagablow, the greater the rate sa evaporation. Kay ang wind, if the wind increases, no, because ang wind is nag-increase siya sa kinetic energy between sa water particles and the rate, no, which the water gets kanang evaporated. So for example, no, kanang during sa windy day, no, kanang windy day, medyo mahangin nga panahon. If manglaba mo tapos manghalay mo during windy day, no, mas dali mauga compared anang moist day. If kanang moist day taas ang relative humidity, no, i-compare nimo kung asay mas dali mauga, it's during no windy days. So kay we have also the water vapor pressure. So it was noticed, no, sa places sa Earth where atmospheric pressure is less, ang process sa evaporation is more, no. Pag gamay ang atmospheric pressure, mas more ang evaporation rate, no. So ang kinetic energy of particles, no, naga-increase and naga-change of status, no, na-change of status nga na-observe. So more atmospheric pressure, the lesser the rate of evaporation, no. So ang rate sa evaporation clearly nagadepend siya sa vapor pressure sa air, no, or the rate at which the air leaves the surface. So ang difference between the vapor pressure and water and the air, vapor pressure of water and vapor pressure of air is primary factor na naga-affect sa evaporation, no. So lahi ang vapor pressure sa water and vapor pressure sa air, no. So we have humidity. So the more water is the more there is water sa vapor, no, in the air, the more it takes time to the water to get evaporated, no. So like for example, good kanang during manghalayta, if taas ang humidity, like I said, the more dugay, no, mauga compared sa windy day. So we have also the surface area, no, magdepende sa surface area sa imuhang mga leaf or sa imuhang crops, and also sa place kung na evaporation process, no. And then nature of evaporating surfaces, all surfaces exposed to precipitation, example building, vegetation, paved streets, etc., no. So depende sa dana. So if ang place, no, so sa mga buildings kung naa man ay unsa may ma-evaporate dira, no, vegetation, paved streets. And then we have the water quality. Like I said, ang salinity, no, maka-decrease siya og evaporation process, reduce vapor pressure, liquid, and then seawater, and also etc. So I have a picture here, A and B. So this is an example, no, kaning A is just, no, kanang normal water or warm water lang, no, nga gibutang nimo da and naga-evaporate siya. So those kanang mga circle dara is mo nang mga naga-evaporate, no. So diri apod sa B is kani siya is kanang boiling water. So daghang kinetic energy, no, kay taas man ang kanang temperature, taas ang evaporation, taas ang temperature, taas po ng evaporation. So nay mga kinetic energy nga nahitabo, the more kinetic energy, the more nga the more kinetic energy, daghang work, no, nga na work done. That is why mas paspas ang evaporation process. Evaporation from water surfaces. So we have Dalton's law, no? So ang Dalton's law is Dalton's law for evaporation is controlled by two factors. We have the wind speed and the saturation deficit. So kaning formula is useful ni siya particularly sa mga oceans. Overland, the situation is more complicated. So Dalton's law of evaporation from free water surfaces is uh, surfaces using this equation, or E is equal to C times the ES minus the EA. So ang E, the rate of evaporation, C is a constant, and ES is the saturation vapor pressure at the temperature of the water surface, and EA is the actual vapor pressure of the air, no? So we have here, no, we have here the formula for C, or the constant, taken from rower 1931. Evaluated the constant C in equation. Then C is equal to 3.30 plus 1.973. U estimated to be at a height of 15.15 meter, and we have the multiplied, no, 1.465 minus 0.00548, no, where P is the atmospheric pressure. No? So based on measured evaporation from the large and small water surface area, rower 1931 determined that the evaporation from the small water surface areas can be multiplied by 0.77 to estimate the evaporation from large water surface areas. Equation 4.20 or 4.21 can be used to calculate wind speeds for the desired height from wind speed measured at other heights. So later on, no, makita nato ning formula on how to calculate the wind speed for the desired height, no, from wind speed measured at other heights. So evaporation from land surfaces. Pan evaporation is evaporation measurements from free water surfaces are commonly made using evaporation pan. So last time ay na-discuss na ko sa inyo ang evaporation pan, no. So nag-expect ko ato nga na evaporation pan nga equipment or instrument dito sa pag-asa, no, sa pag-asa Butuan, but wala di ay. It's because, no, dili manggod agromet station ang station dira sa Butuan, no, dili agromet station ang naa diri sa Butuan. So usually kaning evaporation pan is naa lang ni siya sa mga agromet station, no, where ang evaporation pan is used, no, to hold water during observations for the determination of quantity of evaporation at a given location. Kani siya, no, isa ni siya sa main instrument, no, nga makita sa mga agromet station. So ang pinaka best known nga pans are the class A evaporation pan, no, the one that we discussed last time, katong gi-discuss sa inyo, ha. So meteorological stations, no, the name implies, no, na it is designed, no, specifically for agriculture. So they measured mga meteorological data such as temperature, rain, or humidity, which is useful sa agriculture. So for agromet station, ang evaporation pan, no, ang pinaka isa sa main instrument nga dapat present in that station. So because of the difference in soil texture and in expected soil water movement, it is difficult to generalize on the amounts of evaporation from soil surfaces. For saturated soils, the evaporation may be expected to be like that from an open free water surface. As the water table drops below the soil surface, the evaporation rate will decrease greatly. So evapotranspiration. So For convenience, evaporation and transpiration are combined into evapotranspiration or ET, also referred to as a consumptive use. So evapotranspiration, no, is a combined name for the process of evaporation and transpiration, like I said a while ago. So when water is released into the atmosphere, both processes are involved. So they have been kanang combined into one word to cover all bases. So ang evaporation in evapotranspiration referred to water evaporated from over the land. No? So we have the various methods for determining evapotranspiration. First is the tank and lysimeter experiment. So tank and lysimeter experiment is mga measuring device which can be used to measure the amount of actual evapotranspiration which is released by plants, usually crops or mga trees. So by recording, i-recording mo ang amount sa precipitation that an area is received and kanang amount lost through the soil. So the amount of water lost because of evaporation, so the amount of water lost by evapotranspiration can be worked out by kanang i-calculate nato ang difference between sa weight before and after kanang precipitation input. So, mo na example sa tank and lysimeter experiments. So, second, field experimental plots where the quantity of water applied in controlled to avoid deep percolation losses and surface runoff is kanang measured. So, kanipod nga experiment is kanang mag-apply ka og water and then i-avoid nimo nga kanang deep percolation. So known nga kanang water nga imong i-apply nga dapat dili siya mag-percolate, walay percolation losses and also surface runoff. Tapos and then imuha siyang i-record after kung pila ang kanang nawala nga water. So soil water studies with large number of samples taken at various depths in the root zone. So analysis of climatological data, inflow and outflow methods for large areas where yearly inflow in the area and also the annual precipitation. So we have another kanang definition of evapotranspiration. So potential evapotranspiration, ang rate at which water, if available, kay ma-remove from wet soil and plant surfaces expressed as the latent heat transfer per unit area. Mga naay heat na makakos og energy transfer or mass changes. Mass changes because of temperature sa isa ka unit area and or ang depth sa water per unit time. I-measure ang depth sa pila ang nawala according na siya kay kaning Jensen 1990. And then we have the reference crop evapotranspiration. So it is defined again by Jensen et al. 1990 is the rate at which water, if readily available, would be removed from the soil and plant surfaces expressed as the rate of latent heat transfer per unit area, or expressed as the depth of water evaporated and transpired from reference crop. The leaf surfaces of the reference crop are typically not wet. Full cover alfalfa clips, cool season grass are used as a reference crops. So both must fully cover the soil surface and be fully transpiring, not short of time. Alfalfa is a good reference crop because it aerodynamically more similar to other agricultural crops than grass. So ang alfalfa and clip, kay mga low leaf resistance meaning the leaf has the ability to carry and absorb water vapor. So, according to Jensen et al., no, using daw aning mga crop, no, we will know the evapotranspiration rate. So, ang alfalfa is kanang flowering plant na siya, no? Belong to legume family. So, it is cultivated as an important forage crop daw in many countries around the world. So, it is used for grazing, hay, and silage, as well as green manure and cover crop, which is also, pwede na to siya magamit in kanang determining the evapotranspiration. Evapotranspiration estimation method. So, first, we have the evaporation pan method. Evaporation pan data or kanang EPAN can be used to calculate reference ET or crop evapotranspiration with the appropriate coefficient. Converting to reference ET as in the following equation allows using crop coefficients for many crops with one calibration. So to get the evapotranspiration, no, in a grass-based reference, we have this formula: K pan multiplied to kanang E pan, or the measured pan evaporation, multiplied to factor for converting pan evaporation to ET. So for desert or semi-desert conditions with no agricultural development and bare soils, K pan, or the factor for converting pan evaporation to evapotranspiration, may need to be reduced up to 20%. So if the pan sad is located in kanang tall crops, no, may need to be increased up to 30%, no, according to Allen et al. So this is the kanang pan coefficient, or this will be our reference table, no, where we base atong data if asa naka-place atong evaporation pan. So naa siya kanang natay case A and case B, no. So mo ni siya atong basihan, no, if kanang unsa atong mga data makuha sa atong evaporation pan, no. So naa siya case A where plant pan placed in a short green cropped area, and case B, pan placed in a dry fallow area. And under these cases naatay relative humidity, so mean percent, no, tas naay mga wind speed, no, ang distance, and if low, no, greater than 40, makonsider siya nga low, and medium between 40 to 70, and less than 70 is high. So na siya more than 2. If more than 2 ang imong wind speed, consider siya light. Moderate 2 to 5, strong 5 to 8, and very strong less than 8, no. So we have here na mga data which ato ang gamiton, no, in solving the kanang evapotranspiration. So we have here no, the case B and case A and B. So mo nilahang difference, no. So ang case A, if dry surfaces, and then you have the green crop, no, green crop around sa imuhang pan. So ang wind is going to your pan, no, from dry surface green crop padulong sa imuhang pan. So muna ang case A. So naa kay at least 50 meter or more nga dry surface, and naa kay space pod sa green crop or ginatawag na fetch. And sa case B, no, from green crop, no, mga 50 meters or more ng green crop, and then you have a fetch nga dry surface or walay crop before ang imuhang pan. So mo ni ato ang gamiton to get, no, the pan coefficient. So different local places na asan sila yung mga standard nilang pan coefficient, no, depende sa ilahang unsa ilahang gi follow. So we have an example here. So estimate the grass reference crop if pan evaporation for July 10 and 11 was 16 mm, the wind was 3 meters per second, relative humidity was 50%, and the pan has a 10 meter grass nga patch. So first, ang ato ang una kanang determine is unsa na case ang ato ang gamiton. So it is stated here nga naa siya kanang naa siya 10, no? Naa siya 10-meter grass patch, no? So at the pan has a 10-meter grass patch. So obviously, ang atong gamiton is the case A, no? Ang K-pan daw niya is 0.70 substitute to equation 80, no, is equal to K-pan times the E-pan. So, ang iyang naa siya 10 meter na grass patch, and then naa siya 3 meter per second na wind, no? So we can conclude that diri siya mabilong sa wind speed no nga more than 2, no, ma-consider as under sa light, and nado siya 10 meter grass patch, so under 10, no, sa 10, and then 50% na relative humidity. So sa iyang kanang relative humidity nga under siya sa medium because 50%, so diriya between sa 40 to 70, no? So we have the 0.7, no, then ato siyang i-substitute sa equation nga evapotranspiration, no? So we have here the 11.2 mm na evapotranspiration. So this formula, no, is the general formula kung nga nilang kasimple ang pangutana, no, o if kompleto po ang imuhang given. So we have another kanang method, no, here in estimating the evapotranspiration using the Penman-Monteith combination method. So Penman first derive a combination equation by combining components for the energy required to sustain evaporation and the mechanism for removal of the vapor. The Penman combination equation combined with aerodynamic and surface resistance terms is called the Penman-Monteith equation. The ASCE standardized Penman-Monteith equation for daily time steps. No, so we have a formula here, no, using formula of Penman-Monteith combination. So mo ni nga formula. So mo ni ang mga kanang definition, no, sa mga gipang butang dira sa formula. So reference 80 for a well-watered crop, no. So please memorize this, no, or familiarize this formula, and unsa ang mga meaning aning mga formula, ha. So values for CN and CD, no, CN and CD are given in the table 4.2, no. So naatay short reference crop grass, no, na siya CN 900 and CD nga 4.34. Tall reference crop muna mga alpha. So ang CN, no, CN 1600s and 0.38. So according ni siya sa I10 Fiso et al. 2003. So ang CN muna ang numerator constant that changes with the reference crop, and then ang CD is the denominator constant that changes with the reference crop. The following equation and explanations assume the Penman-Monteith equation will be applied on the daily basis. The procedures and constants are different for other time intervals. The latent heat of vaporization varies only slightly, is taken as the value for T, or 20 degrees Celsius, no, or 2.45 mJ per kilogram, which is the reciprocal of 0.408. So we have here, no, the formula to get in getting the slope of the saturation vapor pressure and temperature curve at a given temperature is computed using this kanang equation. And to get also the net radiation of the crop surface, we have the Rn, we have also the formula, kaning formula 9, and getting the net radiation of the crop surface. So solar radiation is generally measured by a weather station. So net long wave radiation is determined from this kaninga formula. So to get the net long wave radiation leaving the Earth's surface, mo nito ang gamiton ni na formula, So to solve the kanang net long wave radiation leaving the Earth's surface, we have also here the formula for the clear sky radiation, can be calculated using this equation. And also we have the Ra, the extraterrestrial radiation, masolve sa siya using aning kaning equation. So we have another formula here, the dr, or the inverse square of the relative distance Earth to Sun, which is the equation 13, and then the j, or the day of the year given, given by this equation, equation 14. Another formula, for kanang equation for degrees latitude are changed to regions by this formula 15, and solar declination, equation 16, and then sunset angle is given by this kanang equation, equation 17, and psychometric constant using this kaning formula, using this formula. So equation 19, where P is the mean atmospheric pressure in kPa at the weather station with elevation Z in meter above mean sea level. The pressure P in kPa is given by this equation, equation 19. Equation 20, if the wind speed is measured at the height other than 2 meters above the soil surface, the wind speed, or the U2 at 2 meters over a grass surface, can be obtained from this kaning equation, where ZW is the height, or height of the wind measurement above the soil surface, and UZ is the measured of the wind speed at height Z. If the wind speed is measured at a height other than 2 meters over a surface having vegetation taller than grass, such as alfalfa or other vegetation, about 0.5 meter height, and to be consistent with the standardized ET equation, from equation 4.7 or equation 7 ganiya, the following equation is used to translate the wind speed to meet 2 meter above. Another formula, the soil surface, kanang equation 21, and the saturation vapor pressure is related to the air temperature by equation 4.1. Kaganiha, the mean saturation vapor pressure is the average of the saturation vapor pressure for the maximum and minimum air temperature, using this formula, or this equation 22, and the actual vapor pressure can be calculated from equation 4.1, Ito kaganiha tong formula sa evaporation. So using the daily mean dew point temperature, in this kanang equation 23. The dew point temperature is daily available, EA can be calculated using this kaning relative humidity equation, using relative humidity, using this equation. So we have the formula here, equation 24, in getting the actual vapor pressure ng EA. Siya where RH max and RH mean are the maximum and minimum readings of the relative humidity during the 24-hour period in percent. So values for constant CN and CD are given, kaganiha tong table na akong na-discuss for daily calculations. Values for CN may vary with the aerodynamic roughness of the reference crop values for CD with the bulk surface resistance and aerodynamic roughness of the surface. So both were derived by simplifying terms and rounding the result, no, according to Allen et al. 1998. And atay kanang example diri So example, compute the grass reference crop for June 20, 2002 near Bakersfield, California. Na siya ay kanang 35° north, no? Using the standardized Penman month-rate equation and these values na kay maximum temperature na 38 degrees Celsius, minimum temperature na 22 degrees Celsius, maximum and minimum relative humidity 60% and 25%, wind speed at 2 meter, no, na kay 1.5 meter per second, measured solar radiation, and then elevation, and assume G is at 0.0. So first, no, as a solution, first begin the calculations by determining the climatic constant. So i-calculate nato ang mean temperature, no? So we have the formula here. T is equal to 38 plus 22 over 2. So naatay mean temperature na 30. Then calculate the kaning triangle or the slope of the saturation vapor pressure curve, no, gikan na tong equation kaganiha. So input mo ni ang result. So the slope of the saturation vapor pressure is equal to 0.243 kPa per degree Celsius. And then next is i-calculate nato ang saturation vapor pressure at maximum temperature using katong equation ganina. So the saturation vapor pressure, no, mo ni ang formula. So i-review lang to nyo balik tong mga formula kaganiha, mao ni siya. So gi-input nato. So we have, no, the saturation vapor pressure sa maximum temperature na atay 6.625 kPa, and then calculate the saturation vapor pressure na pod sa minimum temperature niya using the same kanang formula, no. We have the minimum temperature, vapor pressure at minimum temperature, no, we have 2.644 kPa. After na to ma-calculate ang saturation vapor pressure sa minimum and the maximum, ato dayon na pong i-calculate, no, ang mean saturation vapor pressure, no. So we have here the mean saturation vapor pressure using the minimum and maximum temperature, no. So we have 4.634 kPa, and then fifth, no, calculate the actual vapor pressure from equation 24 kaganiha. So natay actual vapor pressure, no, using this formula. So we have nanatay ES, so we can and then i-calculate na po nato ang EA. So natay EA nga 1.62 kPa, and then calculate nato ang mean atmospheric pressure, no, of the station using the equation 19 kaganiha. So naatay atmospheric pressure, no, nga 100.7 kPa, and then calculate the psychrometric constant from equation 18 kaganiha. So naatay psychrometric constant na 0.067 kPa per degree Celsius. And determine the day of the year with using the equation 14 kaganiha, J, no. So we have the value 171, and then determine the latitude Indians regions from equation 15. So we have 0.611 regions, and then calculate the solar declination, no, sa equation 16 kaganiha. So natay solar declination nga 0.409, and then calculate the sunset angle. So using again to mga formula na ako na mention kaganiha, we have the sunset angle of 1.879. So solution, no, again, calculate the inverse square of the relative distance from Earth to Sun, no. So we have a value relative distance from Earth to Sun is 0.968, and then 13, calculate the extraterrestrial radiation from equation 12. So we have, no, the value 41.63, and then calculate the clear sky radiation, no, gikan sa equation 11 kaganiha. So we have the value, no, for clear sky radiation 31.27, and then calculate the net long wave radiation. So we have 5.186, no? So calculate the net radiation from equation 9. So nakay value, no, for net radiation na 14.83 rather. So to find the values for CN and CD, no, katong for grass reference natong table kaganiha. So substitute the above values, no, katutanan nga atong na-solve to obtain the kanang evapotranspiration. So we have input all the values. So natay evapotranspiration nga natay na-calculate na evapotranspiration for grass reference nga 6.89 mm per day or around 6.9 mm per day. So I think that's it, no, for this topic, evaporation and evapotranspiration. And I hope, no, nga na-follow lang ninyo ang ato ang discussion. And yeah, medyo daghan kayo nga formula, no, kani nga topic. That is why gustong ta ko mag-meet ta face to face, but since no very limited lang gid atong time and hapit na to ang exam. So please watch na lang ani nga video, and I really hope na gitapos jud ninyo og watch o paminaw ni nga video. So kung advice lang is i-familiarize lang ang mga formula at the same time is i-comprehend, no, kung unsa to'y gipangayo, no, kung unsa to'y gipangayo and unsa dapat nga formula ang ganito. So I think that's it, no. So like I said, please familiarize the formula and comprehend lang. And if you have any question, no, feel free to contact me, no, contact me directly sa messenger para matubag na ko inyong mga pangutana. So I think, no, mora to, and hapit na tong exam. So napako isa ka topic na i-upload, no, later. So the last topic for lecture 4, the groundwater. So i-upload na po na ako later, no, later after ko maka-record. So kanilang sa for now, and see you in exam week. Bye.